Good evening, everyone, and welcome to the today's session of Saturday Talk by Technologies. Today we have Shri Anil Joshi ji to deliver today's session. A brief introduction of Shri Anil ji. Shri Anil Joshi was holding the company's key position of Executive Director of Industry Sector with BHEL, with the responsibility of marketing for defense and aerospace business, captive power and power process plants, and other related functions. Today he is going to speak on the topic electric power scenario and initiatives. Anil sir, over to you from here.
Thank you, Rajesh. First of all, I would like to thank Mr. Abhimanyu and his team for inviting me for this session. And I think this is one of the most good initiatives that JanyuTech is taking by teaching youngsters about various things, particularly things which are not in their original domain. So I would congratulate Abhimanyu ji, and I will also congratulate Rajesh and all the members of JanyuTech for continuing with this initiative of having these Saturday talks, because this is one thing which is very unique in your company. I deal with many companies, and I think that the way you are being able to leverage this every week after week, without fail, I think this is a hallmark of a good company and a good future to JanyuTech from my side. So I'll just begin with the presentation. This is a very vast topic, so I'll just try to quickly scan through the major issues on the power scenario and the various initiatives that the country is taking now. So let us go to the first slide. Can someone change to the first slide? Is it visible?
Yes, sir.
So basically, we all know the importance of power. I think without power, nothing really exists. And any domain that we talk about, I think power is the essential driving force for doing anything. Maybe it is industry, maybe it is defense, maybe it is your own lifestyles. So suppose, just imagine for a moment that we have no power in the next 1 hour, and power disappears from the radar totally. Any power generating station is not there. There's no power storage devices there. What will happen to our lifestyles? What will happen to the world around us? I think the importance of power, I think, is very essential for our survival, for the survival of the human race, and it is very important for our growth. Like without power, we will have no industries. Without power, we'll have no agriculture. Without power, we'll have no defense. Without power, we'll have no economics. We'll have no telecommunication. So the wheels of motion of the entire country, world, run around the development of power, and how we do this generation of power is very important, because now power has a very big flip side of it, that there's a lot of pollution that comes out of the various technologies that power has developed over the years. I think if you look at the history of power development, it all started at the end of the 17th century and 18th century. Most of the work was done by many sort of foreigners, starting with Michael Faraday, Edison, Tesla, Benjamin Franklin, who was a politician, but he was an inventor. So like that, these people contributed to what power we have today. And if you see that, Indians never contributed to power in that way. So that time, probably we were a colonized country, and we didn't really do anything as far as the power generation technologies were there. And our role was very, very minimal, because we had nothing. We had no infrastructure. We were actually a colony. But what has happened after independence, I'll share in this presentation, how India has moved forward, how the things have changed, and how we are now front runners in many areas of technology. So I think it is very important for us to appreciate what we have done post-independence, forgetting whoever is in power, whatever happened, how our technologists have contributed to the growth of power. So I'll just begin with what are the fundamental ways of generating power. So the fundamental ways, as you are taught in college, is fossil-based, non-fossil based. Fossil-based is all your coal, oil, gas, all other ways to generate power, which are through non-renewable resources, as they say. So you have to sort of use them, and they do not come back to your system. And on the other flip side, they give a lot of pollution to the system. So just to tell a brief, because I don't know how many of you are engineers here, maybe if there are some non-engineers, I'll just explain how power is actually generated. Because I remember one time we were having a inauguration by a chief minister, and we told him some jargon about how power is generated. And then she said that I'm not worried, and I don't want to understand what you are trying to tell me in this jargon. I just want my switch to operate and power to be generated. That's all I want. I don't want anything more. So I'll not complicate the whole subject, because it's a very complex subject, how power is generated. But briefly to tell you, in a normal coal-fired plant, power is generated by generating coal in a boiler, which generates steam, which goes to a turbine, which goes to a condenser where it gets cooled down, and then the same water goes back to the boiler. through the pumps. So there's a very simple cycle which is based on Rankine cycle fundamentally, which was 250 years old. So that concept has fundamentally not changed, but incremental improvements have happened over the years. Efficiency levels have come up, new technologies and new products have been introduced in the cycle. And so a lot of digitalization has happened, a lot of process controls have been established. So a lot of things have changed over the years, but the fundamentals of mechanical engineering have remained same. Last 300 years, 250 years, they have remained exactly the same. So now, if you talk of coal, we have two types of ways how coal is burnt in the boiler. One is simply you pulverize it, you make it into small particles, and with air you enter into the boiler, and there you burn the coal, and then you take out the steam from it and run the turbine. Another way is to have the CFBC boilers, which means controlled fluidized circulation boilers. It's slightly complex, but just to understand that the coal quality is very bad, so you will not be able to burn it in way of pulverization. So you do have a system where you actually burn the coal, and the coal particles which are going in the flue gases are actually recirculated through a cyclone separator back to the boiler on a grate. So fundamentally, it's a controlled circulating fluidized bed combustion boilers. So these we use for typically coals which are very bad, like our lignite coals. They are the low quality coals with low calorific value, high volatile content, high moisture content. So these are coals which are not traditionally used. But India has a large reserve of lignite, and lignite you have heard of Niveli Lignite Corporation probably. So they actually mine these coals. And I come to the first slide. So basically, to burn the coal, you have these two basic technologies, and the CFBC boiler gives lesser pollution as compared to a PF boiler, because the coal particle actually rotates inside the boiler. But these sets are right now up till 150 megawatt only, not higher sets. Although the technology exists, but not for higher capacities can't be used. And another difference is whether it is a subcritical boiler or a supercritical boiler or cycle. Subcritical means that the boiler operates below the critical point, which is in thermodynamics point of view, it is fundamentally your pressure of 220 bar, which is around 219 atmosphere, and a temperature of 374, because that is the critical point of water. So any boiler which operates over that pressure is called a supercritical boiler. India has invented into supercritical technology about 2010, 9 to 10. The first boiler was built at Shipat, India. And we have fundamentally nearly 200 subcritical boilers or plants. And subcritical, we are now reaching about 80 to 90 things. So this is a jump because this improves the efficiency by about 4 to 5%. And this is creating less pollution and much better. So right now, as you can see, the fourth point that we are trying to say is that the maximum capacity which India can design today, the entire cycle, without depending on any foreign collaboration or any foreign support, and also source all the parts within India, major parts, maybe 3% may be still imported, but the major parts can be made in India to a capacity rating of 1000 megawatt. Till now, no 1000 megawatt thermal-based plant has been made. But we have the technology in India to make a 1000 megawatt plant. And now on this, I would like to share some points. The thermal plants are primarily base load plants, which run on continuous 3-shift operation at base load. They are very good for your day-to-day thing. They are not peaking plants. What we call peaking plants are quick startup and quick close. Okay, but these plants require 6 to 7, 8 hours to start and 3-4 hours to stop, and they require a cooling down period to restart. So depends on hot start or cold start. So these are plants which are very difficult to ramp up quickly. So they can't be operated very fast. So they can't generate power immediately. So it takes a lot of time to generate power from them. It happens in 7-8 hours. Suppose there's a black start, it will take 8-9 hours to start a plant. And they can't run on low loads. That is a fundamental flaw. Suppose I have a plant of 500 megawatt. I can't run it on say 75 megawatt or 100 megawatt. I can run it to maybe up to 220 to 30 megawatt. So there is a cutoff limit beyond which these plants cannot operate. That is called the base load. You can't go below that unless you design that. I'll come to that chapter later. We are doing a lot of work in that now. How to increase the ramp rate, how to make the cutoff, low cutoff more high. So these are the steps which are happening. So this is a fundamental drawback of a thermal plant as far as other technologies. They are base load plants. They are not peaking plants. They can't be quickly ramped up. They can't be quickly shut off. So these are the problems which this, as far as the need is there. The other problem with these plants are they are highly polluting in the sense that we all know. The world over, thermal plants are being sort of closed down or no new investments are coming. This is happening not in India, everywhere. So fundamentally, there is no money from banks, and there, in fact, there's a coal cess. Coal cess means that if you have to have a coal plant, you have to pay extra money. Banks do not give loans for these plants as things stand. Although some things are changing in India, I'll come to that later. But fundamentally, worldwide, all the technology providers have disappeared. They have shut shop. They're not making these plants because there's a lot of pressure on carbon emissions. So since they are sort of polluting, just to give you an example, 1 unit of power produced from a thermal plant will require about half a kg of coal. 1 unit that you use in your household will require about half a kg of coal. It will require about 120 liters of water, and it will also require generate about 300 grams of CO2, and also NOx and SOx, which are all greenhouses which are dangerous for the environment. So just to tell you how much a power plant heats up water or sort of requires water, just to give you an example, if all the power plants in India today operate, we have about a capacity of 200 plus gigawatts. They will take as much water as the Bombay city thrice that water per day. So whatever is the consumption of Bombay, entire Bombay, all the power plants eat up nearly 3 times of that volume of water. They require that for their functioning. So most of these plants in the new era are coming up in near the sea coasts, where it is easy to get water from the sea. Secondly, it is also easy to get imported coal. So basically, this is a bird's eye view of what is happening. We have to retire a lot of plants which are more than 50 years old. The demand is rising at 7% at least per year. Okay, climate change is also aggregating the demand because now you can see ACs required in every place in the country. Even the per capita income is rising. Population has gone 140 crores. So India is in dire need of power. Okay? As compared to others, our economy is growing. We are looking at e-mobility. We are looking at railway electrification. We are looking at everywhere we need electricity. As I was saying, there's no other space where we don't need electricity. So this is the state of affairs. Renewables, we have already committed 500 gigawatts by the end of 2030. Again, just to come back to renewables, 500 gigawatt doesn't mean we'll generate 500 gigawatt. In a solar plant, unlike a thermal plant, we generate only a minuscule quantity of installed capacity. Right now, we have 50% renewables, but the power generation is nearly 10 to 12% only. So I think you better note that point, that the point of billion units generated is 1/5 of the installed capacity. So installed capacity is actually a misnomer. It is not the correct way of actually assessing. But world over, the billion units are not talked about. The amount of power generated is not talked about. What is talked is what is your installed capacity. So India is doing very well in that. Okay, but the point is that that is why the rush for thermal has occurred. Come to the next slide. Thank you. Next slide. So again, if you look at the energy basket, you see the yellow ones increasing, which are specifying the renewable portion. So our peak requirement is in the energy basket is changing. The coal portion is coming down, but I am very sure by 2032, because at around 2032, government expects another COP session maybe in India. So by that time, India wants to establish all the possible thermal plants that are visualized, so that there is no blame on India that India is not towing the world line on carbon emissions. So probably this is one reason why there's a renewed thrust on thermal, because we are racing against time to establish nearly 80 gigawatt of thermal plants. 80 gigawatt has never been done by the country even in peak time. But the government is pushing now for a galloping space in the next 5 years to establish huge quantity of thermal, and also parallelly going with solar. Okay, next slide. So this is again telling the same thing. I'll just tell you the main crux of India's problem is that the distribution. If you see, the distribution has been decentralized, and like in your Mahagenco is the generating station, but there is a separate distribution transmission arm. Why it is done? Because discoms are a leaking basket in India. They are totally into a financial mess of 70,000 to 80,000 crores. Government every year budget gives your and my taxpayer money goes into that. We are pumping huge money into discoms. But discoms are not improving in India because one is technology, other is agriculture, electricity subsidy. Okay, agriculture power is free. A lot of theft is there. So what do you call this line? AT&C losses, aggregate technical and commercial losses. Okay, this is as big as 22%. Okay, the target is to make it 10%. That will save enormous quantity of taxpayers' money. But again, there are a lot of political issues in this. Okay, you can address with smart metering, you can address with digital substations, you can address with better demand control, better national grid which is smart. Okay, so there is a ways of doing it, but probably our digital this is the biggest challenge in our budget also. How to subsidize the failure of discoms, okay, what they are called as distribution companies, because they are giving power at subsidized rate. We have in Delhi, you have to give power below 200 units free with no bills. Okay, freebies are there. So these are political issues, but also technical. What we call technical in the sense that improvements in digital management of grids. How can you be sure that how much power you need? And unless you have a connected grid, we have a national grid, but we don't have an intelligent grid, a smart grid we don't have in India. So that is our failure of solar as well as our distribution companies. But the biggest challenge, I think, is distribution companies. If you look at the per capita consumption of India, it is still very low. Okay, we have an aspiring population, aspiring youth, but the per capita consumption is abysmal. If you compare to America, it will be 10 times of this. But we are nowhere there. Okay, but still we are not able to meet the power requirement, and still things are getting a bit bleak unless we quickly control these discoms. Next, please. So this is how the government is looking at other sectors which have a direct impingement on your electricity consumption. This is the NIP, which is known as the National Infrastructure Pipeline, which the government visualized, Modi government visualized. So e-vehicles, big way. Okay, you are finding e-vehicles now on 3-wheelers, 4-wheelers, trucks, buses. Okay, government is pushing highways to have Indian Oil is working full time on this. HPCL is working full time on this to establish charging stations. But where will the power come from? Power has to come, no? Power cannot come from here. So if you look at it, all these downstream activities in our economy, like gas pipelines, India is looking at a gas grid, doubling the gas grid. Same way we are looking at doubling the steel production, say aluminum production, everything. Everything requires power. So are we really serious on it or not? That is the question. So although we have a lot of planning, but power cannot come from outside the country. We are exporting power to Bhutan and Nepal, and probably in Bangladesh also we are establishing plants. But problem is that we cannot get power so easily from a foreign country. It has to be done in the country itself. It can't come from here. It can't come through a grid. We can't talk of a national or international grid, as the Indian Solar Alliance talked. One country, one world, one grid, one sun. So that is not feasible practically, considering the technicalities involved. Okay, so we have to have a power inside the country itself. Next, please. So, government talked of Saubhagya scheme that you give power to every household. Okay, so now if you look at it, there is no household in India which is without power. So what the government did, where they could not reach, they gave a solar powered cell and solar lantern. So declared that it is part of the Saubhagya scheme, and India could say that we have now cent per cent each household has power. Okay. But the truth may be slightly different because we have very remote villages still. But wherever for the remote villages we don't have a grid connectivity, we have done that we have provided local solar power. But how far it runs practically, that is a different question. But the effort is laudatory, that the government is trying to see that every house is actually powered. So that's a good initiative. At least we are reaching out to people. Okay, next. So this is again what I talked about, the Uday scheme. Uday scheme is one of the most important scheme to salvage the discoms. So country is trying to take over their interest burden. See, because they are sinking. So government is trying to subsidize their loans, giving them more money. Okay, reducing the power, the saving ATC and losses. How to fund this leaking basket? So if you just see the first line, accumulated losses of 3.8 lakh crores. Can you imagine? So each Indian is actually getting a sort of liability on this value. Okay, 140 crore Indians are paying 3.8 lakh crores of accumulated losses for running your power system. So unless government is trying to do a lot of things, probably it requires a lot of change to make sure that this runs. And look at the policy, why it is happening, what can be done to avoid this. So these are very, very challenging situations, because unless the discoms survive, the generation companies will also not survive. How long can the government subsidize that with your and my taxpayers' money? Okay, next please. So these are some of the government schemes and initiatives which I was just sharing. Next. So again, I will just go to the new hydro policy. I just last slide. First slide before this. First slide. This slide. This basically talks of they have tried to say that you can build in your flood mitigation measures into the cost of the project for hydro. You can. So they wanted hydro to come up in a big way. Okay. So they made a lot of banking and financial jugglery to make sure they are viable financially. Okay. So this is how the government tried to push hydro, but hydro is also coming very slowly and increasing at a very small space because of the civil works involved. Civil is huge in hydro, and secondly, climate change is also affecting hydro projects because now with all these landslides and boulders coming in, a lot of projects are getting silt. Okay, projects are not working in many cases because climate change also affects hydro projects and vice versa. Hydro projects affect climate change because they bring landslides and other environmental disasters. Plus, so another way is to look at low micro hydro, small 5 megawatt sets. So a lot of initiative has been done on that. But again, to take out power from that small hydro is a big issue. So it's a complex thing how to generate power in a country like India, which is so well spread out. Next, so now I'll just continue nuclear power. I was saying that India has done a lot of things. So I'll just come to 2 slides which tell what India has done post this moratorium on nuclear. One is that India developed its own technologies, research. Park was the front runner. Birbal Sahani and other people and Salamji and all these people worked on these technologies. And we have established the stage one is pressurized heavy water reactors, which I was telling you 22 numbers. Pressurized heavy water and non-pressurized heavy water at the stage one, which runs on natural uranium. Natural uranium is fissile material basically. Okay, U-235. But what India did in the meantime is in 2010, we have only a potential of 320 gigawatt hours years of the first one. We have so much uranium to run for only 320 gigawatt years. But for the 42,000 that you see here is based on a technology which generates the fuel. You put in plutonium, you get plutonium as well as uranium. So this is known as fast breeder reactor, which was established in Kalpakkam. So India put a lot of money into this to develop, because that time we said we will not get fuel because of the American moratorium. So we worked on this to see how we can be self-sufficient as a nuclear power country. Because of moratorium, you will not get the technology. So you develop the technology, but also you develop alternative technology which other countries didn't think of. So this fast breeder reactor is a very game-changing technology where you use plutonium to generate more plutonium and uranium, basically fuels, which are used for further. If you see the arrow mark, U-33 is used in the stage 3 plants. Okay. Which is the advanced heavy water reactor. Already Park along with BHL established 300 megawatt capacity, and see the potential how it skyrockets in advanced heavy water reactor. This is to be built probably in Tarapur by Park. So this is the experimental stage. Design work is over, but this is the game changer. Fast breeder reactor and the advanced heavy water reactor, where we will not depend on nuclear fuel, because every time politically we are crushed because we have done the nuclear testing. And there are questions asked in international forums that India will not be supported. So none of these companies support us on this. Although they come in bilateral aid because they have to run their own companies. But this is the 3 stages which nuclear, which is all in-house. Which is post 1969 when we did our first Apsara 220 megawatt in Bombay, Tarapur. Okay, so let us come to the next. So I am telling you that the nuclear program is a very shielded program, not much talked about. Okay, so just this is the thing how supercritical technology I was explaining because of the higher temperature. This is how about 40% are indigenous, but most of the people, including Chinese and other players, have gone away from the country now. They are not existing in the country. People like Dusan, people like G, a lot of people who had come into the country, including the Chinese, are not there now. They have established about 40 to 50% of the supercritical sets. Rest is by BHL. So now there is no other company in the country. L&T is there, but L&T is not playing an active business part now in power stations. So only BHL is left now as an indigenous company to establish the 80 gigawatt that is in pipeline. So, but what I want to say is that now we have, unlike Pakistan, unlike Sri Lanka or all other countries which gained independence around our time, we are far ahead as far as the technological power is, as far as industrial power is. We are far ahead of those countries, and we are self-sufficient. We need not depend on outside world support. We can do all things, including gas turbines, thermal sets, even solar to a large extent, without any outside banking. Okay. So this is just the range of supercritical sets. Now I'll come to the most important part. Next slide, please. Quick. So I think we can skip. We have made a lot of commitments of 50% from this achieving net zero by 2070, carbon intensity. These are all global commitments. Okay, and that is why we are pushing solar over the years to meet these COP26. But now the stand has changed. We are saying India has its own security needs of energy. So we are trying sort of, not backtracking is not the right word, but we are trying to sort of diplomatically get out of this and saying that. Come to the next slide. So again, these are the commitments we have done. Okay, let's skip this. Okay, this again is how our billion units compared. You see the green one in this electricity generation is so low, but the installed capacity is so high. Okay, the green gives you a good idea of, and you see the black one, the second sheet, it is predominant, as I was saying. Okay, black is coal.
So thanks, sir. Actually, I think we can have a same. The subject is very big. Can have one more session on the same subject. My quick question, only one question, is that these advanced ultra supercritical things, is it retrofittable or it has to be a greenfield project?
No, it has to be a fresh. It can't be put into this, but the incremental improvements can be done in supercritical and other places. See, there are incremental improvements. So learnings from this can dovetail to other plants which are running. So not the entire thing, because see, the whole chemistry is different. So maybe some tools that are used there, small tools, just to say that you can have a trick which you can make a retrofit there. Small, but not any gigantic change in the running sets. But the idea is that the future will be this only. So one thing is that you can learn from this. In fact, in Dadri plant, this has been put as a prototype in the subcritical plant, that we are taking temperature 720 degrees to experiment. Same way we can put the incremental improvements back to the other lower ratings in retrofit as you are suggesting. So that will come to it once it is successful, but that cannot be gigantic. You can't make a supercritical plant as an advanced ultra. It's impossible. It's not possible because the whole technology is different.
Okay. One more question, sir.
Yes, please.
Okay, understood, sir. One more question, sir. In all your total presentation, 2 points I couldn't see there. One is the ocean thermal, another is the hydrogen power. Mention name was
very interesting. Hydrogen power is very important. Green hydrogen, everyone is talking. Okay, and already we are talking of one cheap green hydrogen. But again, green hydrogen again will become effective once you have solar power to generate the green power. Because logically, to generate other ways of generating hydrogen are probably too expensive. Okay, but we are trying to see whether our hydrogen can run gas turbines. Okay, there are also experiments I was telling about this methanol to run gas turbines. Hydrogen can also be used as a fuel. Okay, so that also has been talked about. But again, the cost and hydrogen, everyone is dreading because of the dangers of explosion and other things. So a lot of safety things have to be done to experiment that out. Probably we are not a country to experiment, and we don't have the money in hand to go forward in this, except maybe private sector, because they may need to showcase this worldwide. But probably as an investment opportunity, I don't think it's a very good idea to look at. Because there are other options available right now. Like methanol is a very good option. Country is moving totally to make coal to methanol. Okay, if you convert coal to methanol, it's a very good option. You use the coal also and make the methanol also. So that is the type of technology which is needed. Hydrogen is right. And what was your first point? There's the hydrogen.
Yeah, and one more thing, ocean thermal, iodine-based boilers. Long back we have talked, 20-30 years back we were reading about
basically, they have not seen light of the day worldwide. Okay, they have actually remained in the academic books, probably because of the costs that are too prohibitive. So ideas are good. See, even for data centers, they are saying there is an idea of having paint, sort of amalgamated paint, and they can generate entire power. So these are actually prototypes which get talked about, maybe for some funding or other things also, because we are not sure what is the actual benefit of those things. But actually, to see commercial operations, it will take time. I'm not trying to negate that, but it will take time. So let us wait. Maybe our generation will not see that, but maybe future generations may see that. So all these technologies are always changing.
Anil, I have a question. You said something about primary side of nuclear and secondary side. That was not clear.
Yes, sir.
What does that mean?
See, the primary side is where the nuclear fuel is there. Okay, nuclear fuel where the actual the moderator graphite rods are there. This is the primary side, which we call the reactor side, where actually the entire nuclear fuel is kept in. Okay, the secondary side is basically the boiler, the turbine, which takes the steam and runs the boiler and turbine. The boiler is basically a steam generator, which may be inside the primary side also located, but basically the turbine side. Okay, and the peripheral thing, the BOP part, that is called the secondary side of the nuclear plant. Primary plant is where the nuclear fuel resides. Okay, the reactor building, where actually the nuclear actual process happens. But you take that take the intermediate fluid and heat the water in the secondary side, and you take the steam to the turbine. Taking the cutoff from the steam to the turbine is the secondary side. Okay. There you have also a lot of products which are not there in thermal. Like you have a product where you have to dump entire steam into a vessel. Suppose the nuclear reactor is generating power, but you don't have a turbine strip. So you have a lot of devices in the secondary side where you have to keep in all the steam safely. Suppose the nuclear reactor runs, you can't close the reactor fast, but your turbine trips or generator trips, so you have to stop the turbine. So what will you do with that huge quantity of steam? So that comes in the secondary side with a particular vessel where you keep all this steam back safely. So you can't dispose the steam in air. So that is the secondary side, basically. But the more important part is that integration between the nuclear and secondary type is also done by Indian companies, which is very important for the safety of a nuclear plant. What is known as the control center. The merging of the primary and secondary side is also part of secondary, primarily. But a lot of equipment on primary side also a lot of companies are making now, in shields and other things, in piping, walls. Okay, they are all part of the primary side. But the core reactor, where actually the thing resides, is the primary side, which these collaborators don't share. The American companies, French companies, they keep it closed to themselves. Although a lot of research is going on in India in these areas.
So we are not self-sufficient in primary, but in SMR,
to that extent,
are we?
At least 40% components we make in India based on their designs.
But in case of SMR,
yes,
are we self-sufficient?
We can develop. See, it will take time. But again, SMR is a debated concept that we will be able to do. Government is putting a lot of thrust because it's a good idea. For a place like Andaman Nicobar, if you put an SMR, it will suffice the entire island. So SMRs are good concepts. Okay, they are portable. They are self-contained. You can take in a truck and load it. They are factory built. Okay, that we can manage. But when I have talked to nuclear experts in the country, they are a bit skeptical about it. Okay, they say it will take 5 to 10 years to develop the designs which are safe. Okay, in factories. Okay, but I have talked to many nuclear scientists on this. But SMR government is educating, but probably time is not ready. But probably with the budgetary funding, things will be different. Because this time only Bharat SMRs were top in the budget. So, but I think it's a good idea. See, we have to keep all our options as a country open.
Thanks.
Thank you.
Yes, sir. I'm Dr. Senthil. I have a fundamental question.
Yes, please.
As per my understanding, the gas cost per energy unit is cheaper compared to oil. So, I was just surprised, like you told.
No, sir. India is in a very big fix. Okay, I don't think it should be recorded, but India is in a very big fix. The gas prices gas is not there. Okay, I was talking of Enron, this Dabhol plant. Okay, if you run that plant, gas has intensity. Okay, I agree with you of power, but the cost and availability of gas is not there. No? The problem is availability of gas. Gas is not there. Country has LPG pipeline, but that is meant for fertilizers, not for power plants. So only people who are running gas is ONGC, in Uran, in Tripura, OTPC, they are running because gas availability is a question. Availability, I'll tell you, in the case of Delhi Bhavana plant, which is a 1500 megawatt plant, it is costing 18 rupees per unit. Why? Because if you take the gas from, suppose, not to be quoted from Reliance, okay, the price is exponential. Okay, it is not, it is need-based price because the government forced gas turbine units to run gas turbines and show availability because of this year's too much summer. So in April end, the ruling came from the government that you have to make sure their gas turbines, open cycle, combined cycle run. Okay, for that testing also a lot of money was put in by the companies who have captive gas turbines. Okay, so the problem is that the availability, and because of less sources available, the price becomes exponential. ONGC price is much cheaper. Okay, if ONGC sells, it will be much cheaper. ONGC is not supposed to sell to other customers. So we have Bombay High still working to that extent, but it is basically the capping of the oil wells in the Krishna Godavari basin for future generations. So we have struck gas. There is no doubt about it, but it is not sort of available other than fertilizer plants or other chemical industries. So So that is the trouble. If you see here, I think 1 lakh crore to 12 lakh crores of money is stuck as NPA. Okay, I visited nearly 20 plants in the country. In fact, they are giving orders for closing the plant for 5 years to make it safe whenever gas comes back. It is a big question which no one in the country actually talks about.